Hello, Professor. I enjoy the lecture on viruses, but I've been hearing a lot about COVID-19. What are coronaviruses? They are the largest group of viruses in the Nidovirales order. They all are enveloped, non-segmented, positive-sense strand RNA viruses. They are called coronavirus due to their most prominent feature, which is the club-shaped spike projecting from the surface of the virion like a solar corona. They are categorized into four main subgroupings, known as alpha, beta, gamma, and delta. The genome is 5' capped and 3' polyadenylated. There are two flanking untranslated regions and contain several open reading frames that encode multiple proteins. Therefore, at the beginning of each structural and accessory gene, there are transcription regulatory sequences that are required for expression for each gene. The unique thing about SARS-CoV-2 is that it has a large genome and enzymes responsible for replication fidelity that proofreads RNA during replication. Thank you, Professor. I understand what they are, but how do they infect the cell? The S protein interacts with its receptor to attach the virion to the host cell. The receptor binding domain, or RBD, location depends on the virus. It can either be in the N-terminal or C-terminal. The access to the host cell cytosol is due to the acid-dependent proteolytic cleavage of two sites within the S2 portion to permit fusion. In the case of SARS-CoV-2, S protein also has a polybasic cleavage site at the S1-S2 boundary, which permits efficient cleavage by the prototype protein convertase furin. Replicase gene encodes two open reading frames, 1A and 1B, which express two co-terminal polyproteins, PP1A and PP1AB. To express both, the virus requires a slippery sequence and an RNA pseudoknot that cause ribosomal frame shifting from the 1A reading frame into the 1B. PP1A contains 11 non-structural proteins, while PP1AB contains 16. These are individually cleaved later by papain-like proteases, PLpro, and the main protease, Mpro. As you can see, the transcription of a single gene can lead to several proteins. Viral genomic replication is initiated by the synthesis of full-length negative-sense genomic copies, which function as templates for the generation of new positive-sense genomic RNA. These newly synthesized genomes are used for translation to generate more non-structural proteins and RTCs, or are packaged into new virions.